Okay, this time we are going to write an equation or derive an equation for an inverse relationship. We've got some pressure and volume data, and what we're going to need to do is plot that to decide what kind of relationship or what kind of model we're going to use on this. Um, Again, we'll start at 0, and for the x, we're going from 0 to 12. So I got, let's see here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah, that'll work. So I'll go 2, 4, 6. I'm just skipping some stuff to make it not so crowded, easier to see. And this is my pressure data, and that's in atmospheres. And then here I've got volume, and that is going to be in liters. And I've got to go from like 0 up to 90. So let's see here. 10, 20, 30, 40, 50, 60, 70, 80, 90. That's not a very big graph. So let's go 10, 20, 30, 40, 50, 60, 70, 80. Yeah, that'll work. Okay, 30, 40, 50, 60, 70, 80, 90, 100. And I skipped every other. So in between is 5s. So basically every square is worth 5, and down here every square is worth 1. So I can go ahead and start plotting. Let's see here, my first point is at 0.5 and 90, so that'd be up here. My second point is 1 and 50, so that'd be here. And my third point is at 2 and 30. And then I've got, let's see here, I've got 4 and 20, and 6 and 17, so that's 15, that'd be about 17 right there. And then 8 and 15, which is going to be right here. And then 10 and 14, which is going to be right below that. And then 12 and 13. You know, I'm going to move that up just a hair. 14 is going to be right below that. 13 is going to be right below that. So I've got, clearly it's not a line. As pressure goes up, volume is going to go down. We get this sweeping curve that comes down through my stuff here. That is an inverse relationship. So what I've got is an inverse, oops, I've got an inverse relationship or inverse model. So what I want to do is I want to take the inverse of my x-axis. So I'm going to take all my pressures, and instead of figuring out pressure, I'm going to have 1 over pressure. So here I'm going to make another column. And again, this is my x, this is my y. This is going to become my new x, and instead of pressure, it's going to be 1 over pressure. And that's going to be in units of 1 over atmospheres, because I'm taking the reciprocal of both the variable and the unit. So what I'm going to do is I'm going to grab my calculator and do something kind of slick here. Turn it on. Yeah, there we go. I'm going to make a list. In my list, I'm going to put my pressures. So I've got 0.5, and I've got 1, and I've got 2, and 4, and 6, and 8, and 10, and 12. And what I'm going to do is I'm going to make a second list. And that second list, what I'm going to do is call that second list 1, reciprocal, which is raising something to the -1 power. So that's to the -1. I could have also, so let me do this. Um, what I could have also done is 1 divided by the initial list. Either one will work. I hit enter and it fills in all my values. So now what I can do is, I don't know if I can write and look at the calculator at the same time. I think my calculator is going to go away when I start writing. So here's what I'm going to do. I got 2, 1, and 0.5. So this is 2, 1, and 0.5. Let me bring that back. And then the next one is 0.25, 0.17. So this is 0.25, oops, 0.25 and 0.17. What do I got? Whoa, what do I got left here? 0.125, 0.1, and so I got 0.125, 0.1, and then that last one is 0.083. All right, so 0.083. All right, so I'm going to make a second graph. And go ahead and make a second graph here. And my y-axis is going to stay the same, so I'm just going to go ahead and copy this. Go straight down. My values will all be the same. I'm going to write that over that way somewhere. So this is going to be volume again. This is going to be volume in liters. This is going to be 1 over pressure in 1 over atmospheres. All right, so what I'm ready to do here is go ahead and plot my points. I guess I got to put in my scales. This ought to be the same: 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Now, I'm going to go from 0, but I'm only going to go to 2. Here's my max. So, let's see, if I go up by 0.1s, it'd be 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, 1.0, 1.1, 1.2, 1.3, 1.4, 1.5, 1.6, 1.7, 1.8, 1.9. I can actually stretch out the scale and make this work, so let me do that. So I may have to move that, but I can do that in a minute. Let's go ahead and get pen back. So that's 0.1, so this is going to be 0.2, 0.4, 0.6, 0.8, 1.0, 1.2, 1.4, 1.6, 1.8, 2.0. All right, so I'm ready to start plotting. I'm at 2. Do this and get a little fatter pen here. You know what? I'm just going to get a darker pen. I've got 2.0 and 90. So here's 2.0 right there, and 90 is right there. And then I've got, because here's what I'm doing. Let me show you this. I am now ignoring this. This guy right here is my new x. So my next one is going to be 1 and 50. 1 and 50. It's right there. And then I'm at 0.5 and 30. So 0.5 is right here, and 30 is right here. If all goes well, this should be a straight line. 0.25 would be around here, and 20. So 0.25 and 20. And then 0.17. So here's 0.15. 0.17 would be right around there. And 17, which is like in this neighborhood here. And then 0.125 is going to be like right in there somewhere, and 15 is like right there. So these guys are starting to pile up a little bit. 0.1 and 14 is like right there. And then 0.083, that's going to be somewhere in this neighborhood, and 13 is somewhere like right in there. Anyway, this guy is really piling up there. So what I've got is, I've got a line that I'm going to put through this. That is a nice straight line. I get a y-intercept of 10 right there. It's my y-intercept. In fact, let me identify that clearly. That's where the line crosses the y-axis. Right there is my y-intercept. And that's at about 10. So what I need to do yet is figure out my slope. So I'll figure out the slope, and then I will write the equation for my line. So my slope, picking some stuff that hits nice, so I'm going to go there. And another nice point would be like here. Again, I choose stuff on the line. So I got that there. I go down here. I go across here. And I go down here. So my slope is going to be, change in y over change in x. This is my change in y. This is my change in x. I'm going to calculate this by taking 70 minus 35, which is going to be, change in y is going to be equal to 35, and that is in liters, divided by my change in x. Let's see here, my change in x is like 1.5 minus 0.6, which is 0.9, and that is 1 over atmospheres. So this becomes, let's see, I've got 35, oops, 35 divided by 0.9, which is going to be equal to about 39. So we'll go 39. Atmospheres comes up on top because the bottom of the bottom goes to the top, so I've got liters times atmospheres. So that's my slope. So the equation for this line in y equals mx plus b form, y equals mx plus b. So y is volume, is going to be equal to my slope, which is 39 liters times atmospheres. I need the units with that. Times x, but my x-axis is 1 over pressure, plus my y-intercept, which is about 10, and that's in liters. So this right here, this guy right here, is the equation that relates this data.